Okay, welcome to our lesson on completing the square. So this has to do with quadratic equations. So recall that in quadratic equations, there's two ways that you know how to write a quadratic equation. We know standard form, which is where the equation is in y equals a x squared plus bx plus c form, then vertex form. So that's when the equation looks like this: y equals a x minus h squared plus k. So two different forms of the same equation. They're still both quadratics. Remember, I had mentioned, I think, that you can think of these like lines, right? Lines, you have y equals mx plus b form, you have standard form. So it's the same idea, there's just different ways to write the same thing. And the question is, how do we get from one to the other? Well, completing the square is the process which is going to take us from standard form to vertex form. So maybe write that down. Completing the square is the process of going from vertex, or sorry, other way around, from standard to vertex form in a quadratic, or of a quadratic. And there's lots of reasons why you might want to do that. Vertexes, remember, you can always determine the vertex. It's just h, k in this form. So this is useful because you can graph from vertex form. You can determine a maximum or minimum value from vertex form. So vertex form is a useful form to know. So that's why we might want to take a standard form to vertex form. So let's say we have an equation like y equals x squared plus 10x plus 25. Well, this one, you can actually get to vertex form fairly easily. You don't have to do any special process. You can do something you already know how to do, and that would be factor. So if you were to factor this, you're looking for two numbers that multiply to 25 and sum to 10, and the numbers in this case would be 5 and 5. So notice you get the same number, and when that happens we call it a perfect square. The two factors are x plus 5 and x plus 5, which we of course wouldn't write like that. We'd write it like this: y equals x plus 5 all squared. Notice this thing right here is your vertex form. Y equals a x minus h squared plus k. This is in this form. A is equal to just 1 because there's no number there. H is equal to always the negative of this, so negative 5. Right, it's plus 5, but it's the opposite sign. And k is equal to, well, there's no number here, so that means we're adding 0. So the vertex is just h and k, so negative 5, 0. So we can change this standard form to vertex form by factoring. But there's a reason why that worked in this specific example, and that was because it was a perfect square. So we can change to vertex form this case, by factoring, but only because, this is important, only because it was a perfect square. So let's try one that's not a perfect square. So let's say we had something like y equals x squared plus, let's go 6x plus, let's say 10. Actually, let's not say 10. Let's say 8. So this one is factorable, right? Let's try factoring. So y equals x, the numbers that multiply to 8 and add to 2, be 4 and 2. So notice not a perfect square, these factors are not the same. So this is not vertex form. So factoring doesn't give us vertex form. So not vertex form. This is actually what we call factored form, because there's two factors. So in this case, factoring gives us factored form, not vertex form. And the reason is, it wasn't a perfect square. But we can, so if this was a perfect square, by factoring, we could get it to vertex form. So think about this last number here. Let's ignore this last number. Let's say, okay, I don't want that to be an 8. What number do I want this to be? What should the c value, or the last number, I'll say the c value. So remember, c is A, B, C. What should the c value be to make this a perfect square? What number would go here to make this a perfect square? And the answer, well, because this is 6, so we need two numbers that sum to 6. Well, and it needs to be the same number, so what number sums to 6 when you add it to itself? The answer is 3 and 3. So then this number should be the product of these two numbers, right? The product should be 3 times 3 is 9. So I'd prefer this 8 to be a 9, alright? But we make it a 9. X squared plus 6x. Okay, I don't want an 8, I want a 9. So I'm going to write plus 9. Well, I can't just do that. I can't just change the equation. So I can't just write a plus 9 there. But if I want to write a plus 9 and I don't want to change the equation, I need to also write a negative 9. So notice this thing right here is equal to 0. So if I leave the plus 8, all I've done to this equation is insert these two numbers, which is basically 0. So I haven't changed the equation. So now what I'm going to do is group terms. I'm going to group the first 3 terms and then leave the last 2 terms. And what I'm going to do with the first 3 terms is factor them. So notice we made this a perfect square, so this should factor as x plus 3 squared, because 3 times 3 is 9, and 3 plus 3 is 6. Then I have these two terms here, which I can just add together. Negative 9 plus 8 is negative 1. Lo and behold, vertex form. So the vertex, if we wanted to write it, would be negative 3, always the opposite sign to that, and minus 1. So we've changed it to vertex form by this would be the process of completing the square. So that name should make sense because we made it a perfect square. So completing the square, you take a quadratic and kind of make it a perfect square by doing this and inserting the term that you need.